primary goal of carrier screening is to detect couples who are at risk for having a child with a serious inheritable condition. Council pioneered expanded carrier screening and showed that a genomic screen can accurately probe more than 100 conditions.
Over the years, we've learned that not all carrier screening panels are created equal. In fact, medical societies have advocated for greater transparency in expanded carrier screening panel design.
That's why we published a recent paper in Genetics in Medicine. It proposes a blueprint for expanded carrier screening design that best serves patients. The paper answers two key questions. Which diseases do you want to have on the panel, and what do you have to do in order to maximize the detection of at-risk couples?
Given the importance of carrier screening results in reproductive decision-making, candidate diseases should be evaluated against 4 criteria. First, severity. Does the disease decrease life expectancy or cause intellectual disability? Second, actionability. Can patients act on the information they receive? Third, prevalence. Is the disease common enough to be of value? And fourth, analytical sensitivity and detection rate. Can carriers be reliably detected?
Guided by these design principles, we identified 3 key ingredients for maximizing at-risk couple detection. The first is full exon sequencing coupled with real-time curation. The second key ingredient is panel-wide deletion calling. And the third key ingredient is having custom assays for technically challenging genes. To see the impact of using these approaches, let's consider some real data.
In this figure, the area of each rectangle represents the incidence of a given condition. First, we see that technically challenging conditions contribute over a quarter of the incidence. Custom assays for technically challenging conditions, like 21-hydroxylase deficient congenital adrenal hyperplasia, can have a large impact. Second, we see that the most prevalent handful of diseases contribute over half of the incidence. This highlights the importance of detection rate improvements such as copy number deletion calling. Finally, we see that the rarest diseases contribute 10% of the overall incidence. This means that rare diseases, while individually uncommon, can still be important by their combined contribution.
We used this blueprint that we just discussed to create Council's Foresight Carrier Screen, our newly upgraded expanded carrier screen. In the process, we evaluated more than 650 diseases and ultimately selected just over 175 that are serious, actionable, and prevalent. By implementing the findings in the publication, we increased the at-risk couple detection of the panel, and we also achieved a detection rate greater than 99% for diseases like cystic fibrosis and for the vast majority of conditions on the panel.
The principles of panel design that we laid out are going to immediately impact patient care, and I think it's important that we share our knowledge with the medical community.
In principle, we have the technology to add thousands of genes to a panel, but adding 1,000 genes doesn't necessarily best serve patients. So it was really an instructive process to go through thinking about what is the really best way to make a carrier screen, and then to publish on those results. And what was really gratifying was to be able to execute that systematic process and improve our Council Foresight Carrier Screen.